Astronomers spot an interstellar object zipping through our solar system. A newly discovered object speeding through our solar system is sparking excitement among astronomers because it's not from around here. Believed to be a comet, the object is only the third celestial body from beyond our solar system ever to be observed in our corner of the universe. This interstellar visitor, now officially named 3I-ATLAS, became known when the NASA-funded ATLAS, Asteroid Terrestrial-impact Last Alert System, telescope in Chile reported spotting it on Tuesday. Since then, astronomers reviewing archival observations from multiple telescopes have tracked the object's movements as far back as June 14th and found that the comet arrived from the direction of the Sagittarius constellation. The comet's speed and path through the solar system are two strong indicators that it originated beyond our solar system, said Gianluca Masi, astronomer and astrophysicist at the Bellatrix Astronomical Observatory in Italy and founder and scientific director of the Virtual Telescope Project. Masi has been making observations of the comet and will stream a live view of the object on the Virtual Telescope Project's website, beginning at 6 p.m. ET Thursday. The comet is moving at nearly 37 miles per second, 60 kilometers per second, or 133,000 to 100 miles per hour, about 214,360 for kilometers per hour. Too fast to be a local object in our solar system, said Teddy Coretta, an assistant professor at Villanova University near Philadelphia. Objects bound to the sun, denizens of our solar system, take paths around it that return to the same point, Coretta wrote in an email. The Earth's orbit is mostly circular, Pluto's orbit is a stretched oval, and many comets are very highly eccentric. Their orbits are very long and narrow ellipses. This object's path through the solar system is very nearly a straight line. Tracking the object's orbit also reveals the path it has taken to reach our solar system, said Dr. Paul Chodas, director of NASA's Center of Near-Earth Object Studies at NASA's Jet Propulsion Laboratory in Pasadena, California. When we extrapolate its motion backwards in time, we see that it clearly originated from outside our solar system, Chodas wrote in an email. It must have originated from another solar system and probably has been traveling through interstellar space for millions of years until it happened to encounter our solar system. Since the initial sighting of the comet, located for 120 million miles, 675 million kilometers from Earth, astronomers have rushed to observe the object with telescopes around the world. One of those astronomers is Coretta, who observed the comet using the Lowell Observatory's Lowell Discovery Telescope in Flagstaff, Arizona, as soon as he heard about it on the night of its discovery. He said he believes it will only be a couple of weeks before just about every large telescope on Earth and in space has made time to spot and track the comet. People are excited. Almost every planetary astronomer I know immediately ran to a telescope or sent emails requesting telescope observing time in the next few days, said Coretta, formerly a postdoctoral researcher at the Lowell Observatory. While we might have several months to study this fascinating object, the earlier we can figure out how it works, how it is evolving, what strange or unexpected properties it might have, the quicker we can plan for the rest of its passage through the solar system. Anatomy of an interstellar object. Comet 3I Atlas follows to other intriguing interstellar objects, called ISOs, that once passed through our solar system, Oumuamua in 2017 and 2I Borisov in 2019. Both objects, also thought to be interstellar comets, stirred intense interest. The accelerated movements of cigar-shaped Oumuamua even ignited claims that it could be an alien probe. Little is known so far about Comet 3I ATLAS. Astronomers estimate its diameter to be 12 miles 20 kilometers, with significant uncertainty due to the object's brightness, Masi said. However, the comet seems to be the brightest and fastest of the three interstellar objects discovered so far, Coretta noted. 3I ATLAS is approaching our solar system from the Milky Way's galactic center, a different direction than the previous objects, Chodas said. The object has shown signs of cometary activity, including that it appears to be losing mass like a comet. Comets are made of ice, frozen gases and rock, and as they near stars such as the Sun, heat causes them to release gas and dust, which creates their signature tails. But it's not yet clear what kind of material is releasing from 3I, Atlas, or what process is causing it, Coretta said. Considering the lingering disagreements about what caused the orbital acceleration of the first ISO Oumuamua, I'd be surprised if diagnosing and understanding this wasn't a priority for most, Coretta wrote in an email. We don't know where 3I, Atlas came from yet, but as our understanding of the object's orbit increases, we might be able to make some good guesses in a few months. The comet's path astronomers said that the comet poses no threat to Earth and will remain at least 150 million miles to 140 million kilometers from our planet. The comet is currently about 416 million miles, 670 million kilometers away from the Sun, and will make its closest approach to our star around October 30th at a distance of 130 million miles to 110 million kilometers. According to NASA, the comet will also whip by Mars on October 2nd at 18 million miles, 30 million kilometers from the red planet. This is a relatively close pass, astronomically speaking. For reference, Earth is about 93 million miles, 150 million kilometers from the Sun. The nearest the comet will come to Earth is 167 million miles to 170 million kilometers on December 19th, Massey said. Massey said the comet is currently visible in the Sagittarius constellation, which is best viewed from the southern sky in the middle of the night. While the full moon on July 10th will make 3I, Atlas difficult to observe, observations even with small telescopes should improve in the coming months, he added. Astronomers expect that the comet will remain visible for ground-based telescope observations through September before disappearing from view. It should reappear on the other side of the Sun in early December, enabling follow-up observations. It will be observable well into mid-2026, Chota said. Further study could reveal whether comets look the same in other solar systems, Coretta said. Studying interstellar objects is also crucial to gaining a broader understanding of planets beyond our solar system and how they form, he added, describing these visitors as some of the most fascinating things we've discovered. They're comets and asteroids which formed around other stars, the building blocks of planets around those faraway stars, which got ejected into interstellar space, which we later find as they zip through our solar system, Coretta said. We want to measure everything we can about these objects to compare them to our own local comets and asteroids. They're big questions, but the fact that we can make any progress on them by studying these fascinating objects should tell you why planetary astronomers are so excited to learn everything we can about them.